All right, hey everybody. Hopefully everything is going well. These are going to be the notes for Monday, March 23rd. And this is the way we're going to do notes. It's worked pretty well with the 8th graders. They've been letting me know that things are going fine with it. Please let me know if you can't see the video, if you can't hear the video. But I've had absolutely no issue up to this point, so hopefully everything goes smoothly. But you know that a lot of my notes aren't written down. A lot of what I do is kind of added in as we go through the notes. So obviously this is very awkward. I've gotten a little bit more comfortable with it doing it with the 8th grade notes. But I'm looking around our room right now and there's just a bunch of chairs and I'm staring at my phone. So it's a little bit awkward, a little bit weird to get used to. Hopefully this works well for you. I just want to point out a few things. Don't forget that in Google Classroom, let's see, if I get to our classroom over here, go to classwork and you can scroll down until you get to our unit information here. This is going to be, actually, check this one real quick. This is going to be a place where you can get the notes, the unit, the cheat sheets and unit notes, vocabulary and stuff. And I will have your unit notes there. It will have the PowerPoint. It will have the student copy. It will also have a filled in student copy, just in case the PowerPoint isn't working very well for you. But this is the one from last unit. You would just click on the PowerPoint and you would need to make sure that you open it. It's going to be opening in slides. Let's see, we have to, it's going to open up here in the slides. There we go, open in the new window. And then open with Google Slides. And then you'll be able to click the links that are hyperlinked into our videos or to take you to the videos and things like that. I do them all online in PowerPoint and then it transfers them to Google Slides. So sometimes the words might be like a little shifted over or like the arrangement might be off, which is why I have the filled in student copy as well for you. And you can take a look at that. But you just have to run it in the present mode if you want to be able to click on the links and make them work. Okay, so the Bill Nye is there, Study Jam is there, obviously. So that's one way to do it. If you want to just listen to me and go through the notes, and fill them in on your own later, that's up to you. If you want to try to fill them in as I'm talking, that might be more of a distraction. Whatever works best for you is fine. But I would think it would be a little hard to, have, a screen showing the notes and then watch me talk through the notes and then you try to fill in the notes. But that's kind of your call. The other thing is if you feel comfortable and you want to, if you can see it and you can just fill them in right off of, if you're watching it from a computer, it might be big enough where you can actually just fill in your copy of the notes from the screen that you're watching. So whatever works best for you, again, I don't care, just try to make it convenient and helpful. And if it's nicer just to sit and watch me go through the notes and then you fill them in later on your own, do that, okay? In Google Classroom, I will also have, let's say we're gonna do the first 25 slides today. And don't freak out because a lot of them you don't have in your notes, it's just extra information. But if we do the first 25 slides, any slide that has a link for a video or a song, I will point out, but I will also have in the stream under that information. So for, Monday the 27th, I will have in there, is that right? No, Monday the 23rd, excuse me. Monday the 23rd, if there's 3 songs that were in the slides for the slides we covered that day, I will have those linked in there. So that way you don't have to pull up the PowerPoint presentation version from my set of notes. You can just do them straight from the stream. So I've tried to make it as simple as possible for you. If you have any suggestions or there's something that you think would work better, I am all for it. Let me know. I've just been trying to think through how I think it'd be easiest on your end, and so it's there. You can access links through the present mode, or you can access them through the stream. And so hopefully everything is working, and if it doesn't work, let me know, because otherwise, obviously, I had no idea. I just assume everything is good if I don't hear from you. Or if you just want to check in and say, hey, everything's working, that's also nice to hear too. All right, whew. So that's a lot of pre-note information. So this is going to be all about the periodic table of the elements. So we are moving totally away from any other similar topic that we've had so far this year, and we're moving into chemistry. So we need to get introduced to this periodic table. You should have all had hopefully the paper copy of this. If you got the copies from the office, you'll see that I have things color coded here like a key, and then there's matching colors here and here, showing different areas or ways to organize this periodic table. So we will get to this more. One more thing before we actually jump into the notes. If you did not get the paper versions from the office, they are still there. At this point, I don't know if the office is still open or what's kind of happening there, so you need to call into the office. But from 9 to 2, you can call in, and if they're still in the office, they will let you know when you can stop in and pick papers up. The other thing is you can always print these at home. I don't want you to have to print them, which is why I gave you the paper copy or the option to come in and pick that up. And so you should have gotten the periodic table in that packet. You would have also gotten this unit's notes, your copy of them, the Mad Minute, and the flashcards. And I put this in the notes, or in the stream under our information. But if you don't have the packet and you don't have a way to print, you're going to just have to use the computer and use the notes digitally like that. Which is, I mean, it works, it's fine. I know just because we're used to having a hard copy of notes, I would feel more comfortable if it was me having a hard copy, but everybody's different. So if you are okay using the notes off of the screen, then just do that. I wouldn't like that necessarily, which is why I provided you with the paper copy, or they're still in the office. If you want to get them, they are there. Okay. So again, just because you don't have the paper copies in your hands doesn't mean you're like exempt, you don't have to do anything. You'll just have to improvise and do it digitally. The flashcards are obviously available in Quizlet, so you can use the vocab that way instead of actually having the paper flashcards in your hand that you're flipping every day doing your Mad Minute. You can just time yourself for a minute doing the Quizlet flashcard version, of the set. So, okay, hopefully that's all the information. Now let's go. So we're going to be looking at the periodic table of the elements. Here's the link for the BOMI, but I will have that. You should have watched that on Friday, the 20th. And so hopefully you got kind of a good introduction. He gave a lot of really, really good examples that we'll kind of refer back to as we go through these notes this morning. Well, at least it's morning for me. It could be midnight for you. I don't know. All right, so laying the groundwork here. Obviously theories are not going to stay the same. They change all the time. We've talked about this before. Explorers used to think that the world was flat, right? And then eventually you'd keep going and going and going, and then you'd fall off because you'd reach the edge. Obviously we know that the earth is round, and then that was false. We had to take that new information and adjust our thinking. And that's what we're going to be talking a lot about today, is that changing of thinking as you gather new information. Okay, so our ideas and theories are going to change as new information is gathered. Obviously, that's what we do as a species, as a mankind, right? We know that. We have to adapt and accommodate the new information. And this is definitely true of the atom. And you might think that, the atom is the atom, it hasn't changed. Well, it really hasn't changed, but our understanding of it most definitely has. Okay. No one's ever seen the atom up close, but we have a lot of interesting ways to help us know what's going on, and we'll talk about some of those experiments that scientists that came before us have done to help us understand what we do know about the atom. Just like the dinosaur, right? Nobody was alive and saw dinosaurs, but we know a lot about them. Same thing with the atom. Okay, and our theories have had to change as we've gained new information. So, we talked about this in 8th grade, you talked about this in 6th grade, we talked about it in your 5th grade material as well, the atom, All right, so the atom is the smallest particle of an element that retains the chemical and physical properties of the element. So that's the key, the physical and chemical elements. All right, this is, it always reminds me of Johnny Neutron, right? This is kind of the typical way to show an atom. Notice, like from the Bill Nye, he talked about taking like letters plus letters form words. Well, when you take atoms and combine them with other atoms, you get molecules. So you're going to hear that, and we talked about that a lot last unit as well with our states of matter and all the arrangement of those molecules. So letters plus letters make words, just like atoms plus atoms make molecules. And that's kind of a nice visual if you think of that kind of as we go through this. And so the atom has two measurable properties that we're looking at, something called mass, which we're familiar with, and charge. Now last year we talked a lot about charge when we were looking at electrons and those electrical potential energies. And so basically charge is dealing with an unbalanced number of protons and electrons. So if you have 20 protons but only 18 electrons, or maybe 20 electrons and only 18 protons. All right, because we know that protons are positively charged and they're found in the nucleus. Neutrons have no charge, also in the nucleus, right here. So here we have the proton in blue, and then the neutrons are red, and this is all in the nucleus. And then the final subatomic particle is the electron. We're calling them subatomic because they are smaller than the atom, sub meaning below. So we have the 3 subatomic particles, and they all have a specific charge, or in this case, no charge. And you see the electrons are found outside of the nucleus. All right, so the nucleus itself is found in the center, and it's made of the protons and the neutrons. It occupies a really small fraction of the atom, just a really, really small part, right in the dead center. Kind of like if you think of like maybe even like a peach. Think of the pit of the peach is in the middle, and it's really kind of a small part of that entire peach. It actually contains the majority of the mass. Almost all of the mass of the entire atom is found in this cluster in the nucleus. So that's basically the protons and the neutrons exclusively then. And so one proton or neutron is about 2,000 times greater than a single electron. So the mass is 2,000 times more, which is pretty significant. All right, so now we have the electrons. They're found orbiting around the outside. So if this little dot here is considered the nucleus, then these levels outside are where you would find the electrons. So here you see them kind of all like buzzing and moving all around. Here it's showing them in levels just to make it a little bit easier to kind of understand and kind of decipher as we get into valence electrons and balancing equations and what happens with electrons. So this is kind of the model we use for that. But this is probably a more realistic version of what the electrons are doing. They don't stay like in these perfect little rings like around a track. You don't stay in their certain lane. They're kind of more buzzing around in these kind of like bees around a hive is the way I think about them. But atoms are actually able to gain electrons, and if they gain electrons, they're gaining negatives, so now the atom has a negative charge, or they can lose electrons. Well, you're getting rid of negatives, so now you have more positives. The atom is positively charged. And there have been a lot of different models used over the years to show how the electrons are arranged, and this has changed quite a bit. This is a video, and I will have it linked for you in today's information, which again is March 23rd. Okay, so we're going to look at some ways that the atom has, our understanding of the atom's changed. Again, obviously the atom itself hasn't changed, it's just how we perceive it or understand it. So we have Democritus, we have John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr, and then finally where we're at today, which is the electron cloud model. All right, so in about 400 BC, Democritus proposed that atoms make up all objects. He was correct. He thought the atoms looked like a solid sphere. This is where he was incorrect. They are not solid. The Greek word atomos means indivisible, cannot be cut or divided any further, and we're going to have a song that's going to say this: atomos, atomos, everything's made of you. Okay, you'll hear it, you'll know. Can't cut it any further. And he was right. If you divide the atom, you are changing what it is made of. All right, so everything can keep getting split and split and split and split until you get to the atomic level. And then once you get down to a single atom, if you split that atom, then you are changing what it is. All right, and so part of his thinking was correct, but part of it was incorrect. John Dalton proposed something called the atomic theory back in the 1800s. And he said that all substances are made of atoms that can't be created or destroyed. Again, he's following that same line of thinking that everything's made of atoms, and that is correct. And the atoms of the same element are exactly alike. That is also correct. So an oxygen atom is going to be the same as another oxygen atom, unless you have an isotope, which is a version of that. We'll talk about that more here in the next couple of days. And atoms combine in whole number ratios to form compounds. All right, and so we've already kind of talked about that. They're like set proportions. So 2 hydrogens to 1 oxygen make H2O, or water. You have to have it in that set proportion. Okay. And then in chemical reaction, atoms get combined, separated, or rearranged. So he wasn't just looking at an atom in isolation. He was looking at how they're going to interact and behave with other atoms and how they combine, form molecules and compounds and things like that. So he took it even a step further. Then we have J.J. Thomson in the early 1900s, and he actually discovered something about electrons as he was doing experiments with electricity. He discovered that there's negatively charged particles, and when he was kind of experimenting with these things called cathode rays. Now, there are videos that go with this, and I'm going to let them explain that. This is more just for your understanding. I'm not going to test you on the models and the people. It's just so you have a history, a little bit of a background of where all this came from, because you've been learning about atoms and protons and electrons and neutrons for years, but really never known why or how we know what we know. So this, mostly today, we're going to get this history. And again, that is not something that I'm going to test you, and you'll see that through the practice material and the study guides and things like that. Those are not questions that you'll see on the practice stuff. This is just for some extra information. And there will be some things that we cover today that are not on your notes that you need to cover or fill in or anything. Again, this is just for some extra information. So we know that atoms are neutral, and he decided that there has to also be a positive part, because if he discovered that there's a negative part, there'd have to be a positive part to kind of balance or compensate for that negative, right? So he called his version the plum pudding version. So plum pudding isn't something that we usually eat a lot, but it is pudding that has like raisins spread out through the whole thing. So he called, well, actually plums, raisins, you can use both. But he called like the plums or the raisins the electrons, and then the goo or the pudding the positive stuff. So obviously that wasn't quite right, but he was on the right track, that if you have a negative component, you have to have a positive component. And that was really kind of revolutionary kind of thinking. And so we call his version the plum pudding. The plums were the negative, the pudding was the positive. All right, so this part is not in your notes, but the discovery of the electron resulted from studies of electricity using these things called Crookes tubes. And they are carried out at gases at low pressure, and these tubes are called cathode ray tubes. And they ran an electric current through them. And so you have a paddle wheel that's placed on rails between the 2 electrodes, the positive end, which is the cathode, and then the negative end, which is the anode. Okay. And you could see, and there's going to be a video that shows this, you can see as the current is going through, if you have a bar magnet, it's going to react to the ends of the magnet. Obviously, it's going to attract if they're opposite charge, or they're going to repel if they're like charges. And so scientists noticed when the current was passed through the tube that the surface directly opposite that negative end, or the cathode, started to glow. And this video shows that, and so I will have that linked. Now, this one you do need to know. This is called the gold foil experiment, and this is slide number 19, and this goes with Ernest Rutherford. He was actually a student of J.J. Thomson and the plum pudding idea. And he understood and agreed that there was a negative component to the atom and a positive component. And he's the one that helped us realize that the positive is going to be in the middle. And so he performed something called the gold foil experiment. And so he shot alpha particles out of at a thin sheet of gold foil. So the way I think of this is like a piece of gold foil that's so thin that it's only a couple, 3 or 4 atoms thick. It reminds me, and this isn't entirely accurate, but it reminds me like when you guys separate the foil from the gum wrapper, like Extra, I think, has like that real thin foil, and then it's kind of stuck to the paper. And I know like some of my 8th graders, they were in the process of doing that lately, separating that foil. That's what this kind of reminds me of that. As thin as you can imagine, a sheet of gold is what he used. Okay. Most of the particles went right through, and you can see that. He shoots the alpha particles, they go through, but then there's a few random ones that get deflected in strange directions. Okay, so a few were reflected at weird angles, and this is going to be linked, and it will show this process as well. And so what happens is when he shoots it, it made him realize there has to be something in the middle of the atom that is causing those alpha particles to be reflected. And so what he determined is the atom is mostly open space, and you can see that basically from this kind of setup. And that the nucleus is really densely packed, and it has to be positively charged. Okay, because you're shooting positively charged alpha rays or alpha particles through this, and so positive and positive would repel, and so it's shooting out. If this was all negative, it would have just attracted them, and it wouldn't have let anything go through. Right? So 2 super important ideas came out of this: that the idea that mostly empty space, and the idea that there is a positively charged center. Now, in the Bill Nye video, he took that little handheld fan, and it had like the soft blades. And so when the fan wasn't on, you could stick your finger through like the openings, right? You could see the openings of the fan. But then when he turned the fan on and they were flying around, it looked like it was a solid. And that's why it seems like an atom is solid, because you have all these electrons buzzing and flowing around the outside, just like the blades of that fan. It made it look like you were dealing with a solid object, when really you're not, okay? The center is solid, and those blades were solid, but there was lots of opening, all right? Just like with the electrons, and they're buzzing around, but there's lots of openings. It's kind of like a beehive, where it seems like a solid mass of bees, when really it's just buzzing and moving all around, so it seems pretty solid. Okay, and so finally that leads us to Niels Bohr in 1913. He hypothesized that electrons travel in orbits or energy levels around the nucleus. And this is a really useful, practical way. We actually still use this model. You'll use it in chemistry. We'll look at the electron dot model a little bit later this unit, and we use this kind of same idea. This simplifies the idea of where electrons are. So they're not going to stay like in this perfect track, like where it's nice and flat, but this is like 3-dimensional. So these 2 would have this area to buzz around. This next energy level or shell would have this area to buzz around, and then this 3rd energy level or shell would have this outer area to move around. So they have to stay in their 3-dimensional area, but it's not like they're just like on a 2-dimensional flat like circle, kind of the way this shows. All right, so this is a simplified version of what's actually happening, and this makes it really practical and useful for us. Okay, And then finally, this is where we're at today, and who knows, maybe in 15, 20, 30, 40 years, this idea will have changed again. But right now, we call this the electron cloud model, and electrons are traveling more in areas instead of real precise, exact levels, okay? And we call these clouds. So you can see, by kind of the concentration, those levels shown. And again, this is a very simplistic version, but if you take this and make it three-dimensional and let those electrons move all around, those would kind of be clouds. When you flatten them out and make them two-dimensional like this, then you see these nice levels and shells that make it more practical for us to deal with. So we are ending on this slide number 25 for today, which again is Monday, March 23rd. And hopefully you will watch all these videos that go along with it. I know this video was a little long because we had so much of the introduction and stuff at the beginning. I won't always do that, so they'll speed up a little bit. But if you have any issues or if the videos aren't working or something is not right, please let me know. Again, I don't know unless you tell me. So have a fantastic day. I hope everything's going well, and be healthy and safe out there.